Welcome, Algebra 2 students, to week 3 of distance learning. Last week, we finished up the chapter on sequences, series, and number patterns, like your Pascal's triangle. And this week, we're moving into studies and distributions. We will have 2 lessons this week, one about studies, and then the other about the normal distribution. So think of your bell curve. So we're starting with the first one, studies. Now let's look at the definition and terms that you need to know for this section to help you solve the questions. Parameter is a population characteristic. When you hear commercials on television about needing people from 65 and older to test out an experimental drug, that 65 or older is a parameter. It is a population characteristic that they're looking for. Next is a statistic. A statistic is a sample of the population. Bias. Bias is a misrepresentation of the population. A good example of bias would be the way that you ask questions. So, for you taking a survey or a poll, and then the questions say, do you prefer an exciting action movie or a boring drama movie? That would be a bias. Then we have the 3 types of studies. Your 3 types of studies, starting with survey and poll. A survey or poll is where you collect data responses. Most of you have seen a survey or at least participated in a survey before. So that one is probably the one everyone is more familiar with. Next, observational study. Observational study and experiment, our third one, are the most confusing, and people a lot of times mix the 2 up. The difference here, an observational study, is a sample being measured or observed. So when you think about an observational study, the main thing to think about is, are you introducing anything new? Are you experimenting on the drug? Are you using an experimental group? Because an observational study, you are just simply measuring or observing your population. For the experiment, you're actually testing. You're testing a sample using an experimental group and a control group. Now we're going to go ahead and look at some examples. These examples are going to be dealing with your terms, whether it be, is it a biased question? What type of study would the example be? And then finally, how to design an experiment or a survey. So example 1. Example 1, we're going to try to figure out, is it a survey, poll, or observational study, or an experiment? The yearbook staff wants to study whether students prefer a print copy of the yearbook or both a digital and print copy of the yearbook. In this case, all they need are responses, so the best study for this is a survey or a poll. You either prefer one or the other. Example 2. A research company wants to study smokers and non-smokers and whether after 10 years of smoking, your lung capacity has been affected by the smoking. Take a minute, see if you can figure out which one of those it might be. If you guessed observational study, then you are correct. I wanted to ask this example specifically because this is one of those examples that students sometimes get mixed up on observations versus experiments. When you're talking about a research company looking into smokers and non-smokers, I think you have to understand that they're not introducing anything. They're not experimenting anything. They're not making people smoke or not smoke. They are simply observing smokers and non-smokers and measuring their lung capacity. Because that's the case, an observational study is the correct answer. And then finally, example 3. For this example, we're just looking at the bias. Is this a biased question to ask in a survey or a poll? Don't you agree that the cafeteria should serve healthier food? Is it biased or unbiased? If you thought biased, then you are correct. Because of the beginning of the question, don't you agree? You have made your population think a certain way. Because the way the question was worded, you are going to cause a bias and you are going to cause most of your responses to be answered in a certain way. So in this case, you would cause your responses to be more yes. Another example of a bias question was from the beginning of this video when I asked about boring dramas. Wording for questions in your surveys or polls can cause a flaw in your survey by having a biased question. When looking at surveys and polls, you want to make sure that you have unbiased questions. Otherwise, the statistics that you gain from that survey or poll may not be accurate. If you want to design your own survey or poll, then you must follow 3 steps. Step 1 is to state your objective. What are you trying to determine from the survey or poll? Step 2 is to identify the population. Whom are you going to give the survey or poll? Make sure that you're conducting this randomly so that you do not have a flaw in your survey. And then step 3, write your questions. Just like we mentioned in example 3, when you write your questions, make sure they're unbiased. Watch your wording for each question. So if you're trying to design an experiment, you're going to state the objective, determine your experimental and control groups, and then describe the procedure. Now that we've looked at the terms and the different types of studies, what you're going to see below is the assignment dealing with studies. In the next segment, you're going to see the normal distribution or the bell curve, the empirical rule for the bell curve, and z-score. Welcome back. Now we're going to look at the normal distribution. This is the second lesson for this week. The normal distribution, best way to think about it is the bell curve. The topic is one of my favorite topics in Algebra 2. It's so unique, but it's fascinating. What we're going to be looking at is based on a bell curve, we could figure out exactly what percentage a particular point, a particular statistic could be in that bell curve. Here we have the bell curve. When you see a couple of these symbols, I want to make sure that you understand what they are. The little M with the tail is the mean, so the average. And then the 0 with a tail is standard deviation. That is a statistical measure from the mean that will encompass a certain percentage of your data. In this bell curve, we have a line in the middle, that's the mean. And then the next line out is going out 1 standard deviation both directions. So 1 standard deviation. Then if you go out 2 standard deviations, you get to the next lines. And then 3 standard deviations give you the lines that are the furthest to the right and the left. There are percentages within each section. So within that 1 standard deviation, it's mirrored on both sides. 34% and 34%. So within 1 standard deviation, you have 68% of your data. When you think about this, just like your standardized testings, sometimes they stated you are within 1 standard deviation measure of blank. That's what we're looking at with this. 68% within 1 standard deviation. 95% is within 2 standard deviations, and then 99.7% is within 3 standard deviations. So if you break that down, you have 34 and 34, 13.5, 13.5, and 2.35. These are specific and will allow us to know at what cutoff line things may be to create a 68% of the data, to create 95% of the data, to create 50% of the data. And then a formula to go along with this is going to be your z-score formula. The best way to think about the z-score is it is a number of standard deviations away from the mean. And a lot of times what I use for students is to say point, whatever the point is that you're looking at, minus the mean of the data over the standard deviation. And that's just simply another way of writing it. Once you write these down, we're going to do a couple of examples dealing with each. We're going to do a couple of examples dealing with this bell curve and the empirical rule, and then a couple of examples dealing with your z-score. Okay, example 1. There's like 4 examples within this one example, but we have a test average of 68 with a standard deviation of 8 points. So we're going to be utilizing the empirical rule for this example. To start, we're going to be renaming these means and standard deviation pieces. 68 is your mean, so it goes in the middle, and then the standard deviation of 8 points on each side. All we did, put 68, add 8 going up, subtract 8 going down. Now we have questions that ask, what percentage of students are over the grade of 68? What percentage are between 60 and 76? What percentage are between 76 and 84? And then what is the probability that you made more than a 92 on this test? Starting with the first one, over 68. 68 is the mean. It is the dead middle of our data. So over 68 is the upper half. Between 76 and 84. Between 76 and 84. That is between 1 standard deviation above the mean and 2 standard deviations above the mean, which is 13.5. And the last one, the probability that you made more than 92. 92 is way up here. So 92 is 3 standard deviations above the mean. If you look at 3 standard deviations above and below, that's 99.7%. If you take that out, you're left with 0.3%. 0.3% is not our answer. The reason is because that is included on both sides. 0.3 is the chunk above and the chunk below. We have to take half of that, half of 0.3. Or 0.15%. If it gave you the number of students testing, say there were 300 students that took this test, that came up with the average and the standard deviation. There are 300 students that took this test. If you wanted to figure out how many actually scored above 92, you would take this percentage and multiply it by that number. So if there were 300 students taking the test, you would take 0.15%, so 0.0015, and multiply it by 300. And that would give you the number of students who scored above a 92. Now let's look at the z-score and how to calculate the z-score and what it means when it comes to the normal distribution. So for the z-score will tell you exactly where it is in terms of the number of standard deviations away from the mean, either above or below. What these z-scores can do is they can be converted using a chart to find the exact percentage where that point lies. Utilizing the last example, if you figured out what your test score was, you could calculate the z-score and then convert it to figure out what exact percentage your test score was in comparison to the entire class. Now let's look at this example. There are 2 examples within this one example. We're going to determine the z-score, talk about how to convert it, and then see which one we did relatively better on, the first test or the second. Test 1 had an average of 45 and a standard deviation of 10. We scored a 60. For the second test, you had an average of 70 with a standard deviation of 8, and we scored an 87. Starting with test 1, we're going to calculate our z-score. Test average is 45. That's going to be your mean. Your standard deviation is 10, and the point you're using is 60. 60 minus 45 over 10. 60 minus 45 over 10. $60 minus 45 over 10 is 15 over 10, or 1.5. Now let's look at test 2. You had the average or the mean is 70, standard deviation of 8, and the point we're using is 87. For the second test, 2.13 is your z-score. So because test 2 had a better z-score than test 1, you did relatively better on test 2 than you did on test 1. If we changed it to 70, then we would have 70 minus 45 over 10, which is now 25 over 10, or 2.5. So if you scored a 70 on test 1, even though it's not as high as an 87, you did technically relatively better on test 1 than you did on test 2. What these z-scores represent is where exactly it's located on this bell curve. 2.5 means it's 2.5 standard deviations above the mean. 2.13 is 2.13 above the mean. To figure out what exactly these z-scores convert to percentage-wise, I'm going to post a z-score chart. To convert your z-scores to the percentage on the chart, what you're going to do is you're going to go down the left side, 2.5 or 2.1, and then go over the hundredths, and that's going to be your percentage. When you convert 2.5 over to figure out the exact percentage, you would be at 99.4% of the class and the data. Down here, 2.13 would be at 98.3% of the class or the data. Now that we've finished looking at z-scores, what you're going to see is I'm going to post the assignment for z-scores and the empirical rule in normal distribution below. Feel free to reply, post questions, or email questions. I'll be glad to answer any of the questions that you have as you're working on this assignment. I hope that you guys have a great week, and I hope to see you guys soon.